The next thing you want to do is you want to hit the Run Jacara button, which is going to bring the PV Designer up. So depending on the internet speed, alright, there we go. So this brings the questionnaire up. For grid tie systems, we can either select disk or SSEG, which stands for Small Scale Energy Generator. For now I'm going to keep it disk so that we get a one-to-one forwards and backwards. SSEG is going to have a different tariff. You're going to have an import and an export tariff, but for now let's just keep it simple. I'm going to leave it on disk. So we're going to select our grid tie system, so we can either select grid tie with the SMA inverter or grid tie with a Fronius inverter. For now we're going to do a Fronius because we want to do the ESS a little bit later. Alright, so that's the first thing. The second thing you've got to do is you've got to select your current AC distribution. So in single phase, three phase, or unbalanced three phase. Single phase is relatively simple. You're going to get one grid tie inverter. Three phase, you're going to get a three phase grid tie inverter, but you're going to get the number of inverters that you require. Or if you select unbalanced three phase, you will get three single phase inverters for a three phase system. The reason why you would do that is very often you would have unbalanced phases, especially when it comes to smart grid systems where the inverters have to throttle individually depending on what's happening on that line with consumption. For now we're going to keep it simple. I'm going to select single phase, country selection, very simple. I'm going to simulate the system down in Cape Town. The island monitoring is not applicable. Cell phone reception, I'm going to change the grid tie monitoring to I want online monitoring. The other important thing, especially for the solar installers, is the margin slider. So the margin slider, when I leave it on 0%, that means everything charged in there is charged at the standard recommended retail price of the manufacturer, plus then 4% consumables and 8% for installation. So that's sort of an industry norm. If you, however, get involved with projects or a larger system or family or whatever you want to do so that you give them a discount, then you would slide it to that side. So the margin minus 10 means that there's 10% deducted off the entire system and 10% off the 8% consumables, as well as 10% off of the 8% installation and 4% consumables. So 10% basically deducted off the entire system. If you slide it to the positive side to compensate maybe for some traveling or other reasons, then you can do that. I would, however, advise you, if you want to be competitive and not price yourselves out, keep it at 0 or close to the 0 mark. If you push it up to plus 20, you're not going to get a lot of work, and minus 20 you're not going to make a lot of money. Okay, so once we've selected the grid tie Fronius open, the questionnaire pops at the bottom. So it's very simple to answer. It just gives you a couple of things to think about. Firstly, let's start with the PV modules we want to select. So I'm just going to select the first one on the list, which is the Canadian Solar 270 watts, a 60 cell module, and size for actual power. So the size for, let me maybe explain that for the guys that don't know. Size for relates to the inverter that you're going to get. So if I say size for actual power, it runs a simulation on the panels based on the orientation and the direction of the panels, and then it looks at what the panels are actually going to generate. That then determines the size of your inverter. If you say rate the inverter for rated power, then it looks at the number of panels times the wattage of the rating. So in this case, if there's a 270 watt and I include 10 panels, then it's going to rate for 2700 watts. So I prefer to use the actual power. Gives me a little bit more flexibility when you design on roofs that that face east and west and different directions, very often you would get a smaller inverter than you would have expected, because the combined rating of the panels is slightly less than the rated power. Okay. The next question is a very simple one. How long is the cable run from the PV modules through to the grid inverter? I'm just going to fill in 25 to have a value in there. So it's important that you put the cable run in there. The number of strings that you require, you'll get that number of cables in the final system. Okay, so inverter to DV board cable run, I'm just going to put 10 in there again. That's just the cable run question. Annual shortfall. So the annual shortfall is on grid size systems, because you can't net export over a year. You obviously want to have a shortfall, and this question relates to how big do you want that shortfall to be. So Jacara is going to come back and recommend a number of panels. So if you want a 10% shortfall, like I put in there now, then Jacara will come back and say you got to mount 10 panels or 5 panels or whatever the case is, so that you get that shortfall which you're designing for. I would recommend you don't go less than a 10% shortfall, otherwise in certain seasons, because of the fluctuations of the solar panels across seasons, in certain seasons you'll be net exporting. Okay, the next thing is the registrations. To keep it realistic, I'm gonna select COCT, which stands for City of Cape Town, and registrations is basically, sometimes there's a cost that you've got to add onto the PV system for registering it with certain municipalities or so on. So in this case, City of Cape Town, because we're operating in the Cape Town area, I'm going to include the City of Cape Town cost. The COCT registration is about 7,000 Rand for the system, and if I add the COCT plus SSEG meter, I think the SSEG meter is another 7 or 5,000 Rand, so it's going to be in the region of 12,000 Rand for that one. So City of Cape Town, I'm going to include that for 5,000 Rand, and then the cost will be added to the system. Alright, bump grid inverter. Very often a client wants to install only a few panels, maybe start the system with 5 or 10 panels, but then as time goes on he just wants to add panels to the system, but he doesn't want to necessarily buy a bigger inverter or buy more inverters later on. So because there's such a small difference in the cost of a 3 kilowatt versus a 5 or 8 kilowatt, it's sometimes handy to say, let's put the bigger inverter in now and later on just add panels to it. So if you don't want to add extra capacity onto the inverter, you just put a 0 in there. A 0 will basically give you the smallest inverter that you require for the job. If you want to, however, step the inverter one size up, then you would add a 1 in there. If you want to step the inverter to 2 sizes up, you would add a 2 in there, and that's how it would continue. For now, I'm going to keep it on 0, so we get the smallest inverter, assuming the client doesn't want to upgrade in future. Alright, so with everything done, we're just going to say submit. Depending on, again, on the speed of your internet, some information exchange is happening, and Jacara comes back with a recommended panels. So a lot of people think we have to add exactly that amount of panels, so it's not the case. Jacara allows you to fiddle around with it. So panel count, although Jacara recommends 10 panels, we can say I want to add 12 panels, or you can do 8 or whatever you want. On grid size systems, I would say let's maybe listen to Jacara for the first round, add 10 panels. The next thing you got to do is select your mounting system. So I'm going to keep it simple, add a tile roof. Orientation is which direction does your panels face. So 0 is obviously north in the southern hemisphere, and negative is west, and positive is to the east. So if I say positive 45 degrees, then it means my panels are facing 45 degrees to the east of north. If I say negative 45 degrees, then it means that my panels are facing 45 degrees west of north, and you can go right round through to 180 degrees, which means the panels are going to be facing south. For now, I'm just going to leave it on 0. which means my panel orientation is north. Sometimes you, after maybe your first iteration, you want to come back and change that. If you see the client has an evening bias or afternoon bias, it's maybe better to see if you can't find a west facing roof that will suit the orientation of the panels better. Okay, so then the next question is the elevation. So that's the pitch of the panels. This client, let's assume it's got a 28-degree pitch. It can be pretty much anything, depends on the roof pitch of the client. For now, let's just use 28. Once you're done with that, it's very simple. You hit the save button and then you wait for your PV system.